Hey everybody, I'm Altan, one of the founders of Nuffle Labs. Yeah, perfect. Oh, how do you? Yeah, perfect. Yeah, just wanted to give a brief introduction about myself. I was born and raised in Turkey. Studied computer science at Imperial College London. I did AI. I still have questions about how AI works, so that's in crypto. I was a partner engineer at Near Foundation before we started Nuffle. Love for Labs actually was born out of Near. Was previously called Near Modular. We did this website called nearmodular.com. We started our endeavor pretty much last year, August, when L2s were taking off. We saw OP Stack and Base actually sort of like being part of the crypto Twitter and started asking ourselves how to use Near's sharded infrastructure for building L2s. And I'll briefly talk about how we started sort of thinking about this process and how we started Near DA and then started building on top of it. We just announced Nuffle Labs 3 weeks ago, and the two co-founders are actually here, Frat and Sam. That was a 13 million fundraise led by Electric. So what do? But we're the builder and amplifier of Near Protocol's modular product suite. So we have two core products. That's Near DA. That's because sharding is actually pretty good for data availability. So I'll go deeper into this. And we also have a AVS built on EigenLayer, which does fast finality layer. That has been quite a bit of interesting discussion around pre-confirmations and others. So we'll give an introduction as to how we do that. They're targeted towards scaling and expanding Ethereum ecosystem, but currently been using Near's core primitives, but eventually will use other primitives as well. So what does that mean? Well, so Near DA is pretty much a stateless smart contract. So what we do is we use a communication primitive between shards on Near. So we use that primitive to build a linearly scalable data availability solution. It leverages Near L1. It leverages consensus algorithm of Near, and it gets Near protocol security and to provide DA for Ethereum rollups. And the second product, which is building on top of Near DA, is the which is the Near DA solution to store rollup sequences. So we look at the sequence and then store that sequence. Does this work? No. Yeah, we store that sequence. This should work. We store that sequence in Near DA for a short amount of time. That's 70 hours. And then EigenLayer operators grab that sequence and prove state across L2. So you can pretty much prove the state of OP, Arbitrum, or any other rollup that uses Near DA, and we provide that state to cross-chain applications. So I'll give an introduction as to how that would work. So yeah, just to give an overview, like how does Near protocol work? There's two sort of, in a blockchain, there's 4 different components, which is consensus, agreeing on the state of the blockchain, execution, which is basically executing those transactions, settlement layer is where the finality happens, and obviously data availability layer that essentially stores the sequence of the transactions, and other validators can grab that sequence and sort of like continue the blockchain. How we think about it at Nuffle is basically there's Ethereum L2s, there's an Ethereum L1, and we basically sort of like export Near's data availability to rollups, and we basically build something on top that does like 3 to 4 second finality using EigenLayer. So how does Near DA work? We can think about sort of 3 different components on the L2. There's a batcher, which publishes the transaction ordering to Near DA. There's a proposer, which submits Near commitment to Ethereum. There's also a rollup node that essentially drives the blocks and executes those transactions to get a state n+1. And the benefit of this is that we have consensus around the blob, and what we do with the receipts as well, that we don't occupy the consensus with more data than it needs. We actually prune the data after 70 hours. If you want to come after and use that, you can use the archival node service. Yeah, so eigenlayer. Why do we care about eigenlayer? So historically, when you're building an L1, you had to bootstrap your own validator set. And we use eigenlayer to essentially, if we're going to do a new service, how do we bootstrap it, sort of an off-chain service using the security that Ethereum provides. Near essentially historically built sort of 200 plus validators from scratch. It takes a lot of time to build that. It took almost 4 years to build that. And our approach has been, you don't need to build a new L1 or an L2 to do a service. We can just use eigenlayer to provide that. And yeah, Near DA is obviously built on Near's crypto economic security, and you also get eigenlayer crypto economic security. So you combine them for the fast finale layer, which is just gives you a better security system. And yeah, I just put this from eigenlayer, which essentially gives you a bit of a code what eigenlayer is. Yeah, so we talked about modularity. Obviously, modularity is great, but there are sort of problems that we see. The first one is obviously fragmentation. There's tons of L2s launching right now. I think there's 50 on L2 Beat. One of them uses Near DA today. And, but the problem becomes now is like, how do you operate between those two L2s? How do you build a DEX? How do you move assets? Everybody that is in the Cosmos ecosystem would know using Osmosis is a bit of a pain. How do you solve that problem? The second part is obviously terrible UX. When you're bridging, so I bridged actually yesterday from Solana to Ethereum. It still takes a lot of time, and Wormhole still charges, I think, quite amount of money. And also terrible security. When you have a bunch of blockchains lacking security, not only on the, obviously L2s get some sort of Ethereum security, but also L1, you get a terrible security as well. So how do we solve all these problems? So yeah, we basically come with a conclusion that Near DA is not enough to provide that security, and we basically went to, yeah, so we, anyway, I can't read this one, but, so yeah, it comes with NFFL. What is NFFL? So it's a fast and secure settlement layer. Basically leverages both Near and eigenlayer security to provide interoperability. If this works, does this work now? Perfect. Yeah, so NFFL leverages both Near and eigenlayer to provide a interoperability primitive by verifying state at station secured by restaked ETH. This allows obviously participating networks to access state across L2s in a very fast way. Just before we start, obviously, it's nice to talk about the jargon that we'll use. There's a bunch of things that you use on eigenlayer that's hard to understand for some folks. So liquid staking tokens, that LSTs, that essentially when you put the stake into the tokenized representation of restaked ETH, you have staked assets, which is on eigenlayer, it's native ETH and LSTs. You have actively validated services. That is essentially any off-chain program or pretty much like verifiable cloud that requires crypto economic security to do some productive work. A good example of this is EigenDA in the eigenlayer ecosystem, but you're seeing 28 different AVSs that build on top. Oracles are a good example as well. Operators, they take sort of ETH restakers and do something with that restaked ETH. They can opt into different actively validated services, so they can run more than one, almost like a application. And aggregator in our sense, which is we aggregate signatures using BLS for state proofs. Now, what are the components? Well, Ethereum is the first one, right? You have a SFFL smart contract there. That is essentially just interacts with the eigenlayer contracts. On Near, you have the DA smart contract. We can do that for all the rollups that post on Near DA, but we can also do it for the larger rollups, such as OP, ARB, anything, as long as we have access to the sequencer. We have on the rollups a verifier contract that essentially checks network state attestations. And off-chain, obviously, there's the operators that run the AVS software to provide attestations, and an aggregator that essentially aggregates all the signatures from the operator and gives it to users to use it. This is how it looks like on the infrastructure graph. So you have the network side, obviously. You have Near, which the DA smart contracts live, which is the Near NFFL that has operators that are off-chain.
that are contributing and testing to the aggregator. And finally, they submit a checkpoint to Ethereum in the middleware contracts that I talked about that talks with the EigenLayer core contracts. So on the Ethereum side, obviously, it's pretty easy. Restakers, if you're restaked to EigenLayer, you restake that capital to EigenLayer core contract. There is basically what we call is the middleware, so that allows us to talk to the EigenLayer core and then the off-chain components. Those contracts pretty much enable the interaction between the off-chain nodes and the EigenLayer protocol, and then the restake ETH basically restake to operators, who then becomes the validators to validate the AVS. Pretty much, they become the validator of the network just by the restaking. The other part, obviously, that's important is when we look at the network and we dump the sequence to somewhere, the data needs to be available. So we use near DA for that for now. That's because we built it. But essentially, we can use other DA services such as EigenDA and Celestia that allows us to sort of not only take near, but also other components as well. There's also obviously a block relayer that takes the sequence and constantly post that to near DA. And that relayer is pretty much a sidecar, so you don't have to change your sequencer implementation. You can just run it on side rather than within the sequencer. The other job of an operator is to look at pretty much run an index or a near full node and extract that data and essentially run a full node or get the state attestations from Infura to pretty much compare the data across the sequence and the node. And that allows us to get, obviously, the final state, and everybody attests to that final state, so there's some consensus around that. And yeah, so operator off-chain nodes, their job is to sign a message and attest to the state. We use BLS signatures from the operators. When the desired consensus is reached, let's say 66%, these are aggregated into one sort of interface and made it available through the API. And aggregator's job, as I said, it collects the signatures, and the API could be used by, let's say, a cross-chain DEX, cross-chain game, to get that state and push it to network 2, where they can build a cross-chain application. So how does this work in practice? Well, let's say there's an application that wants to deploy on 2 L2s. So it wants to send let's say this is a message for message passing purpose. It wants to pass an hello message from network 1 to network 2. The message eventually goes to network 1. It finalizes on network 1, and all the operators agree on the state of the network 1. The application provider can take the message finalized, the state finalized from the NFFL, and push it to network 2, where they can do whatever they want to do with it. So possible applications of this one, you can build a cross-chain DEX. We're actually exploring that with a bunch of application builders on different L2s. You can build a cross-chain landing platform. You can pretty much land across, let's say, OP and ARB. You can build a cross-chain social application. So Lens is about to do an L2. You can use this protocol to do something on the Lens L2, and then by the result of that, do something else on OP, let's say. You can build fast bridges. That's probably the easiest application you can see. Pretty much anything that can combine 2 or more different blockchains that needs to finalize in 3 to 4 seconds. So the roadmap, how does that look? We've released this last week, and we're pretty much working on near DA and FFL at this point. So you need to basically prove the transactions that happen on Ethereum. We historically worked with Succinct, but we're now switching to Jolt. There is this upgrade coming up in Near called stateless validation that decentralizes the protocol and reduces the requirements to run a validator. This actually helps Near DA because it can scale more. We currently have 24 megabytes per second, but with more shards adding, we can increase the throughput of the data availability layer. The other interesting thing is chain signatures. Obviously, in Near, a Near account can drive different L2 or L1 pretty much wallets. So you can use that protocol to do interact with an L2 and then use the NearDA to be able to sort of like natively talk between different L2s. The other thing we're pretty much thinking about is, well, NearDA has only Near's cryptoeconomic security. How do we add more cryptoeconomic security, such as from Ethereum using Eigenlayer or something else like Babylon, and make the system a bit stronger cryptoeconomically? And in terms of NFFL, we'll launch on mainnet in August. We're going through audits. We're looking actively to get applications to build there. And the other thing we're exploring is, well, you can use, obviously, Eigenlayer security, but how can you use other assets to sort of secure this layer? As I mentioned, we can actually add more DA layers on top of NFFL. It doesn't have to be NearDA. We can actually add EigenDA, Celestia, or others to have more optionality. And finally, just improvements, basically testing and ensuring that everything works. So that's been the kind of the focus of a currently 5-people team. So we're very small, but hiring to 9 people. Yeah, so my Twitter, which is here, and Nuffle Labs actually got suspended yesterday for no reason, so we're trying to figure that out. But my Telegram is here as well. If you have any questions, our CTO is here, so reach out to us if you have any questions.